Well, I guess it's 11 o'clock. Want to welcome everybody to the Cover Crop 101 little webinar that we're putting on here today. I'm Craig Dinkle, the crop production agent for the Midway Extension District. Then Clinton, if you can introduce yourself.
Yeah, sure. Hi, everybody. Thanks for joining in today for this webinar series that Craig and I are doing. As he said, I'm Clint Laughlin. I'm the livestock production agent for the Midway Extension District, which is Russell and Ellsworth County. And happy to have everybody on today.
And before I hand it over to Deanne, just if everybody can make sure their mics are muted while presenters are going and videos are off. But of course, if you need to ask a question with any of the presenters, just unmute and ask it. And then also I'll be watching the chat if you have a question there. Like I said, our speakers today, Deanne Presley first to start us off, and then Dr. Peter Tomlinson, and then Dr. Jamie Lynn Farney will end it talking about grazing livestock with cover crops. So Deanne, if you want to go ahead and get yours loaded up.
All right, there we go. So I'm going to change. That'll work. That'll work just fine. So can you see it okay?
Yep.
Okay, great. So I thought I would lead off today talking about soils, building better soils. And then I know what Peter's going to talk about, and Jamie Lynn's going to talk about forage at the end. So I'm not going to get into forage too much other than to say I think it's a really excellent way to utilize cover crops. So like I said, though, I will stay out of her subject area. So this picture, I want to tell you a little bit about it first. So we have been doing a project in Northwest Kansas, and I don't actually have the data written up yet, but these are 3 different soil profiles. They're all within about a mile of each other, and one of them is actually it's the farthest right one is a prairie soil, and then the one in the center is a cover cropped soil, and then the one on the left is a soil that's it's tilled and there's no cover crops used in the soil. So we have been doing a project doing some comparisons, and they all look a little different. They were taken on different days with different sun exposure on them. I haven't adjusted them in any way, but I just think about this is the kind of work that I like to do. I like to compare different soils and think about how are they different and what is their productivity, both now and in the future. So that's kind of a background to the work that I do. And so when we talk about soil health, it's defined as the ability or capacity of a soil to function. So for a soil to do what a soil does. So one of those things is productivity, right? So what is the absolute productivity of that soil, whether that's used for rangeland or used for cropland? But then also soils have other functions as well. So we can measure physical, chemical, and biological properties. And then I think about organic matter. Is organic matter a physical or a chemical or a biological property? And the answer to that, I'm going to say, is yes. I think it's like the seat of this stool. So if you think about one of these sort of being physical, chemical, and one's physical, one's chemical, and one's biological, I sometimes think about organic matter as being like the seat. It's connected to everything, and it's a chemical property we can measure in a lab, but it affects the physical properties a ton. And then the biological properties or measurements, which is, I know Peter's going to talk about that. Those obviously they are partially the soil organic matter, but organisms also build the soil organic matter. So that's why I say it's connected to everything. And how long does it take to change your soil health, whether that's the organic matter or whether that is individual other properties? That depends. And I'm going to talk about some of that as we go. So some other soil functions besides productivity. but nutrient cycling. So all of these nutrients go through different phases. So the mineral phase and the organic phase. So they're cycled. So as residue breaks down, these minerals become more available. And then water relations. So if you think about whether rain goes into the soil, so I think about precipitation, capture, and storage. So as water moves into the soil, it's captured. If water runs off of the soil, it's runoff. And we know what that takes with it. It takes sediments, it can take nutrients, it can take pesticides. So, and in a dryland environment like yours, or I should say Western Kansas, because you could be watching this from anywhere in the world, I guess. But thinking about Russell, Midway District farmers, when I say this, I would say that we know that water is precious, a very precious resource. And so precipitation, capture, and storage is so important. Diversity and habitat. Again, this is a little bit more of Peter's area, but both for microbes, but also for many other organisms as well. And then how does it work? So one of the many areas that I cover is septic systems. And so wastewater disposal, putting septic tank effluent out into a soil is actually an excellent treatment for that wastewater, because soil is a filter and it detoxifies, and the organisms break down substances that are in that, and also cycle nutrients that are in that as well. So soils, when we talk about soils and its ability to function, that's what we're really talking about, is can a soil do what a soil needs to do? So soils, I've talked about building soils. I also just want to talk about where soils come from. So I'm a pedologist by training. So that means that's what I think about, is where do soils come from? And this is a map of mollisols. So mollisols are the very best soils in the world, really. And we have a lot of them in Kansas. We're mostly covered up by mollisols. So there's two different kinds here, so wetter ones and drier ones, but mollisols are the very best soils. So we've got high natural productivity to our soils here. So they come from the climate, they come from the organisms, so whether they were developed under prairie grasses or under trees. Relief, so where you are on a landscape matters, right? We know if we're on the side of a hill, there's a tendency for higher erosion versus at the bottom of a hill, there's accumulation of soil. And parent materials, so this would be, are your soils glacial material, or are they from a river, or are many of ours, especially in the area, the Mid-Kansas district, they're from the wind, so less derived soil. So it's actually picked up and it's deposited the very best particle size for growing crops. So silty soils are the very best ones in the world for growing soils. And then time. So it takes time. It takes a long time for soils to form. They form from the top down. And that factors in to that question of building a soil. So what is the difference between these two photos? And I say the hint is that it's 150 years. So these are over the fence line comparisons of a prairie on the right versus a cropland in the left. And these are same lighting, same everything. These are lab benches, under fluorescent lights here. So this is same everything. And this is really just showing erosion, right? So loss of organic matter can come from two things. So we can have erosion, whether that's with water or by wind, or also with tillage and oxidation of this organic matter. So really breaking it down, what was normally this dark black color, decomposition, and speeding it up with tillage by stimulating organisms. So most of our soils, this says cropland is generally 40 to 60% eroded relative to the adjacent pasture. Again, this would be for the uplands. For the bottomlands and cropland fields, they've gained a lot of that topsoil. But if you go with an upland position, there's been a lot of erosion. So I say that that's the bad news. And also humans are the sixth soil forming factor. We're kind of an organism, but we're sort of our own factor because we're so dramatic is what we do. So I say the bad news is that we've done a lot of we've degraded soils a lot, but the good news is that research says we can improve soil health. So I'm going to talk about this. I'm not going to go into weeds so much, but cover crops and weeds is a huge area of research and showing a lot of promise. So let's see I'm going to focus on soil physical properties because I know what Peter's going to talk about. He's going to talk about other things, but I'm going to talk about the physical properties. And again, because it all comes down to precipitation capture and storage, and also stopping erosion, turning it around and building soils instead. And I like to measure things. So physical soil properties that we can measure and reversing the effects of degradation. So this is just a simple graph. And because I'm going to talk about aggregates a lot. So this is a very simple graph that shows some interesting things. So here I have the axis over here. This is actually millimeters. So think about how big a millimeter is. Some of these, so a 4 millimeter aggregate, that's the size of, maybe one of those really small croutons at a salad bar. And so tillage is shown here in purple, and then there's some other treatments here. So the red ones all involve rye, either alone or as a mixture. And these are a cover crop that were planted in the fall. And the green ones are spring cover crops. And so this is Wichita. Well, this particular soil near Wichita, this is a really sandy soil. So I think it's a loamy sand. And it is beat up. It's a pretty terrible soil. This is low organic matter. And so what we were doing in this study was adding cover crops actually by Wichita. We have a horticultural experiment station. So K-State does. So the Hort department, and they asked if I would help with this study. Peter was involved too. And so we measured the aggregate stability. And so what's neat about this graph is just by adding cover crops in after the third year of the study, we saw tremendous differences between where we were doing tillage every year, twice a year, versus adding in cover crops. And so I just have a quick little demo here of what wet aggregate stability is kind of about. So we actually do this with a machine over time, but this is a simple visual. So one day I just did this in the lab and took some pictures. So this one says conventional, no-till, and native. They were all, they were on the same section of each other where I took these. And so I dropped those in, and then if you look at it from the top, so this is a slaking test. Again, I would normally do this with a machine in the lab and be more precise with, weigh out the soil. But this is just to visually show that there's a difference here. The conventional falls apart, and this one is, like I said, no-till. This is long-term no-till, and the water is instead of the aggregates just exploding. So if you think about it, what's going on is there is air inside there, but to get out, it explodes the aggregate, versus here where there is better stability, there are pores, and there's organic matter and biological exudates holding this aggregate together, so the air is actually able to bubble out more slowly. So what happens during a rainfall event? Water can go in rather than the aggregates all exploding and water sitting on the top and then eventually running off if there's a slope. So with soil health, organic matter is the key. We think about it a lot, right? So this is a study where both soils, there was a conventional tillage and a no-till, and both soils received the exact same nitrogen rate, which was 135 pounds of nitrogen for 30 years. And one was tilled and the other was not. And it led to a very big difference in organic matter. So this is about 3% versus a little over 2%. That's a big difference for organic matter percentage. And it was at the surface only. So at about 2 inches is where the difference was. But once you got down below 3 inches, there wasn't a lot of difference between them anymore. And the other thing is that the density of the soil was quite different. So with organic matter, we all know that that's something we want. More is better, always better for organic matter. With density, you want a lower density. So plant roots need to be able to go into the soil and go out and explore the soil profile as much as the soil profile as possible. Well, density, you want it to be less dense. And so then if you look, so soils that generally that have more organic matter have better aggregation, and better aggregation also means that it's less compactable. So you can traffic across it, you can drive across it, and it has, because organic matter also has elasticity as well. And so those are some tables where you can look those up. And that one was a silty clay loam. So that particular soil texture. So anything over 1.5 would be bad. So 1.25 versus 1.35, that's a pretty big difference, but 1.5 is where we start worrying about the plant's ability to go explore and get any resources in a silty clay loam soil. So same thing. And this is actually, remember back to the Wichita soil, I said was a terrible soil. It was loamy sand. So just as the aggregates were, the aggregate stability was very low for the tillage, this is how many minutes it took to infiltrate 1 inch of ponded water. So in this case, you want a low number, right? And here we see that the tillage had around maybe 25 minutes or so to infiltrate 1 inch of water versus, considerably lower where we had cover crops. And that was not quite statistically significant. We'd want to see that at 0.1 or maybe 0.05 would be even better. But the point is we're getting there. It's getting close. And so the two are very related. That's the whole point, is that aggregate stability and infiltration go very nicely together. So now I want to talk to you about a study that's it's a little old, but it's awesome. So I want to talk about it. And then I'll talk about some newer stuff in a little bit. So this was a project that was done in Heston. So Heston, on the way to Wichita. So between McPherson and Wichita is where this is. And this is a sticky soil. So it says silty clay soil with lots of smectite. Oh, and the rainfall is 27.5 inches. And so this is a winter wheat grain sorghum rotation with that went on for 15 years. And where they put the cover crop was after the wheat. So in a 15-year rotation, or in 15 years, there was a cover crop in there 7 or 8 times. And so their cover crops were either sun hemp, which that's the genus and species for sun hemp. And so it's a legume, or there was also a late maturing soybean in the study as well that they used as a cover crop. So it didn't put on any seeds, they just destroyed it. And other things that if you don't want to use sun hemp, cowpea is a good one. Like I said, soybean and mung bean is another one that a lot of people are using as a cover crop, summer legume after wheat. So what I want to show you here is that after 15 years, the 0 to 3 inch soil organic carbon differed. So if you want to convert between soil organic matter and soil organic carbon, I take soil organic carbon, and if you multiply that times 1.7, that gets you soil organic matter. So if you look at this one, so let's see, the no cover crop, it had basically 1.4% soil organic carbon. So if you multiply that times 1.7, I'm just going to round that to 2 just to keep the numbers easy. So let's just say that this one was the no cover crop had about 2.8% soil organic matter, and the late maturing soybean was about 3.4% soil organic matter, and the sun hemp was around 3.6% organic matter. So these little letters, these mean that these were in fact different. So statistically, these were different. So this wasn't just one sample taken in a bad spot. No, this was a bunch of samples, probably, I'm going to say 16 samples or so at least for each one of these bars. So this was a real difference. So the organic carbon was definitely different. The organic matter was definitely different where you had a cover crop, whether it was soybeans or sun hemp, versus no cover crop. And this was all no-till, and this was all well-managed no-till. So we had a big difference. But what is also interesting is that below the 3-inch depth, there was no difference in soil organic matter. So I've heard some people say, there's no difference. Well, let me tell you, the surface, when you have the surface, whether that's the top 2 inches or top 3 inches, when that's improved, that makes a world of difference for other things, such as infiltration. So this is the time in minutes for water to move into the soil. So in 180 minutes, there was 2 inches of water total that went in where there was no cover crop. This is about 4 inches where there was a soybean cover crop, and about 6 inches where there was a sun hemp cover crop. And this is ponded. So what we did, we pound these rings in, and the night before, so we were out there with big tanks of water, filling up the rings with water. So we soak it all up. And then we come back the next day, add a bunch more water and watch it soak in. So in other words, this is saturated, ponded infiltration. So this isn't starting off with different water depth. One wasn't drier than the other. These were all the same moisture content when we did this. So these are drastic differences in infiltration. Again, why? Goes back to this. We have drastic, these are pretty drastic. These are pretty large differences in soil organic matter between these. These different treatments, and it led to drastic differences in infiltration, which is what we want to see. And so is that cause and effect, or did it have anything to do with the worms? So we had drastically different numbers of earthworms where the cover crops had been grown. And here's the fun thing about this. This was in December 2009 in grain sorghum stocks. So the last time the cover crops had actually been there and actually been growing was like 13, 14 months, because the covers had been grown after the 2008 wheat, and then they would have died or been sprayed out in the fall of 2008, the covers would have, and then grain sorghum was grown in 2009. So in other words, they were in a habitat. They found their plots they wanted to be in, and they stayed in those plots. That's where they lived out their life. So I know a lot of people sometimes talk about green living roots, and I think that is important. But even the fact that you could have a cover crop in a field every other year, and it makes a world of difference. So worms still preferred those cover crop plots. And this is a Darwin quote. So worms prepare the ground in an excellent manner for the growth of fibrous rooted plants and for seedlings of all kinds. And then this is I went to a zoo with my kids one day. When they were little, and there was the zookeepers were spreading honey on this window so that this sun bear would lick the window. And because normally they would use that for sticking their tongue in rotten logs to get insects. And so sometimes people ask about, should we add microbes to our soil system? And I think, well, it's kind of like smearing a honey on the window, it would be, zoos exist, but I mean, I'd rather see a sun bear in nature, right? So give it the my point is this, that if you give the microbes the habitat, or in this case, not even microbes, earthworms, the habitat, they'll be there and they multiply. And there's no cover crops. There were some there, but where you built the habitat, they multiplied and flourished. And then does that feed back into better infiltration, better organic matter? Probably yes. So I know, like I said, this study's a little old, but it's just always going to be one of my favorites because there's so many connections there. And then an economist made this graph and said that the better soils were actually more productive too. So there was a nitrogen rate in this study so the 0 versus 30 pounds, 60 pounds, and 90 pounds. And this was the nitrogen applied to the sorghum. So the sorghum yield after those cover crops. And they said that these, the boost comes from the improvements in soil productivity. And for sun hemp, this persists even with the increasing nitrogen. So again, why it's a classic is because it every component went well and worked well in the study. And then there's really nice ongoing work in Western Kansas being done by Augustine Obor and John Holman. And then Logan Simon is the grad student, and Craig Rosaboom, he's on campus. He's a cropping systems person. And this reminds me of the fact that you can find a lot of our research online. I actually start by going to New Prairie Press, and then I just type in cover crops, and I see all the different things. And I noticed that in 2020, there's been 20 different K-State reports written on cover crops already. Well, I mean, okay, we're almost at the end, but I think 20 that's a lot. I always say there's a lot of different people doing a lot of different kinds of cover crop work in Kansas. Again, I'm a soil nerd. That's what I focus on. But some people are focused on the forage, and some others are focused on the weeds. And that's what's great, is there's so many people doing different things. So this one was at Garden City. And so there was a fallow treatment, peak for grain, cover crops standing, or cover crops hayed. And I'm going to focus on the soil properties. But they, in this, They measured both the bulk density and the soil organic carbon. And that's pretty important because of the fact that sometimes if you just look at percent soil organic carbon, it can be misleading, especially like if the things you're comparing are really different. Like if you're comparing a fluffy tilled soil versus something that's maybe pretty dense or pretty compacted or something, it's really good to have both the bulk density and the carbon, because it's a way of sort of going from apples and oranges to making them all on one level playing field. So going from percent, and when you have the bulk density and you know the depth that you sampled, you can multiply those things, and then you can get to like tons per acre, which, for example, if you're looking at being involved in any of those carbon trading programs, that's the kind of way that they're going to be trading, is on tons. How many tons of carbon emissions can you offset by growing cover crops for one of the big companies? So, I mean, I assume that those companies are going to be the ones doing those bulk density measurements and the sampling measurements, but the point is that's the way that it's going to be traded, so it'll be measured that way. So in the study, they had bulk. So they started in 2012 and they checked on it again in 18 and 19, and so they had the bulk density and then they did the carbon. And so here they've already gone ahead and done the measurement. So these are not in any kind of percent numbers. So what you see is they aren't showing a big difference in the carbon over time, but they did show that overall, I think they said on average, let's see, bulk density. So they aren't seeing a big difference in the bulk density. So I'm skipping out to the 18. So they did see that the fallow, like in the fall of 18, the fallow was a little bit denser than where they had grown cover crops, but no differences in the treatments in the summer of 19. And again, by 19, they're not really seeing any differences in the carbon stocks. But they did note that it's interesting that across the board, they're seeing they were thinking that they were starting to sequester some carbon. So then this is showing the stability of aggregates. Again, back to how well do they hold together in water. And so they were seeing that the cover crops, whether they were standing or hayed in this experiment, had a little bit better mean white diameter, so a little bit better stability where they had cover crops in 18 versus not in 19. So, and that one is in very far southwest Kansas. And this is another where they had looked at the very largest aggregates. So when we do this, we put them in a stack of sieves and got big aggregates, which are good. That's like having a lot of A's and B's. And you don't want to end up with a bunch of little tiny ones that fall out the bottom, very smallest sieve. That's like getting B's and F's. So you want to have more large aggregates. So they were seeing that they were, in fact, for the very largest aggregates, which is in the farthest right column, that they were seeing more large aggregates where they were having cover crop as opposed to fallow. And so the point again is that this is helpful for stopping erosion, which is bad because that's flat out losing soil, which we don't need to do any more of that, and also water infiltration for capturing it and storing it when it does come. And so then the last thing I'm going to talk about is this, their ongoing study, same people, with also Sandy Johnson involved. So this is where they're actually grazing cover crops, and this is at the HB Ranch outside of Hayes. And so this is the dual use of cover crops for forage production and soil health. And so they found, because a lot of people wonder about cattle and compaction. I mean, it's one of those things that's been, people have worried about this for probably 50 years and wanted to measure it, especially in a no-till system where we're not doing tillage to loosen up the soil. Is that going to be a problem? And so here they had some different, and this is the other reason I gave you the this place where you can go read more about it, is because if you want to know a lot more details of how many animals and how many days and things like that, those details are in there. And so they've done this study since 2015, and they're finding there's no negative effects on the bulk density. Again, so if they were compacting the soil, they should be seeing denser or higher numbers. And in fact, kind of across the board, the density is going down over time. And they're not seeing any difference between whether it's fallow or oat triticale for cover, or oat triticale grazed, or oat triticale hayed. So that's really good news. And then the organic carbon, they are seeing this is in the 0 to 2 inch depth. So far, they're not seeing any differences. If there was differences, these letters would be different from each other, but so far they're all the same. And then in the second, this is in the 2 to 6 inch depth, they are seeing some little difference where there's a little lower carbon in the fallow versus in the cover crop treatments. So that's interesting. And then I want to tell you about a do-it-yourself Slakes app. So if you are interested in science, you want to do your own science project, there is an app on the Google Play Store only that has not gotten released for the iPhone yet. But it's a free app, and you can take pictures of your very own soil falling apart in water, and then it'll give you a number, give you a numerical rating and say whether that's a stable soil or an unstable soil. And I've tried it out a little bit in my lab, and I've got a student doing 100 and some samples for an honors project she's an undergrad. And so it's early, but it's pretty promising. Some people have been publishing on it. And so if you wanted to do your own comparisons. So I'll just conclude and say some properties are slow to change, like soil organic matter is a pretty slow number. It's a big pool, and it's kind of a small fraction if you think about it. If soils are like if organic matter is like 2% out of 100% of the soil, that it's kind of a small number, and it's sort of slow to be able to see changes, but you can see a lot more immediate results for both, erosion losses that you can visually see. But like I say, fixing the surface is so important for precipitation capture and storage, or when rain does come. And that really starts with aggregate stability. And then just, again, building soil health and most productive soils, I think they're linked very strongly. So with that, I'll take any questions you have. I'm going to get out of presentation mode so I can see people again. There we go.
Does anybody have any questions for Deanne? If not, I can ask one. For this part of Kansas, Deanne, moisture can be quite variable. We came off a couple really wet years, and now it's looking like we're going back to dry. What effect does that have on like building soil organic matter?
On building soil organic matter. Okay, I thought you were going to talk about water for content for crops afterwards.
Well,
okay. But for soil organic matter, the point is very valid. So if you look at like a bullet point list of factors that increase soil organic matter, for one thing, you can build organic matter faster in a soil that has some clay in it. And it's really hard to build in a sandy soil. But if you look at it overall, in theory, more water means more biomass. So more plants, more roots, more above ground too, but most soil organic matter really comes from the roots. So in general, more water, more plant growth equals more organic matter accumulation. So if we end up, let's say, turning, let's fast forward 50 years and overall we're a little drier and drier over time, that's going to start to pull organic matter levels down. It really would. Sometimes I just imagine, like, what if Kansas turned into Oklahoma, and then you give it 100 years to settle? I mean, equilibrate, yeah, organic matter should start coming down. If rainfall goes down and if temperatures come up, that's kind of like cooking all the organic matter. Not all, but it would start to pull organic matter levels down.
Okay. Well, and then the other one, like I said, one of the challenges in this area is on the balance between, how much that cover crop, say you had some rye and radish mix out right now, how much is that crop going to use and possibly hurt your cash crop, say like corn or sorghum in the coming year if we don't get that recharged? I mean, is there any studies on that?
So I was just looking at one that Augustine is doing. So it's in a wheat sorghum fallow system. And I don't know. and it was showing that a cover crop, so he has a spring cover crop planted. So after, yeah. So it's basically cover crop versus fallow. And he wasn't finding a lot of difference in following wheat yield. So you have to ask yourself, okay, so what system, where's the cover crop? So I'll go back to what you said. So you said cereal rye out now, and then going into corn or sorghum this spring. I mean, there could be an effect. So I think that's like, not going to steal any thunder from Jamie Lynn here, but did you use that cover crop to raise some pounds of beef, and what were they worth? What were those pounds of beef worth? Or is this a straight up cover crop? If this is a straight up cover crop, it gets a lot harder to monetize, I'll tell you that, especially if there is a crop yield loss. So there could be, and that's why, I mean, I think more research is needed. Again, in a non-livestock situation, I think the key is going to be to keep the biomass short. I wouldn't let it grow real crazy. I think the biggest reason to do it in that scenario where there's no livestock is for weed control. So keeping weeds held back, there'll be less of them in a unit area, and they'll be shorter and easier to kill. I think really it's for weeds is why you do it.
Okay. Looks like we got a question in chat. Do you know if there has been research in the Great Plains on using anhydrous versus liquid or dry in and effects on soil health?
Oh man. So the reason I'm happy to hear that is because I know Peter's on here. So Peter, if you want to warm up and get ready to answer that. But I will say, okay, research, I think Peter's going to be more able to answer research-wise. But I can tell you, Peter, are you there? Do you want to take this one just straight out, or you want me to just take a stab?
I'm here. You can start, and I'll wrap up.
Okay. So what I know about anhydrous is this: it'll kill some, it'll kill any of it contacts. So knocking back a population is usually not a good thing. But I know that they don't go to zero. I know that you don't eradicate earthworms with anhydrous. Because I still see them in fields where people use anhydrous. Now, are they at the same numbers? What does the research say? That's where I probably have to hand it off to Peter. Peter, have you ever looked that one up?
I have not looked that one up specifically, although, you know, in my routine kind of monitoring the literature, I have not seen a direct comparison between anhydrous and either liquid or dry. But you know, if we think about the characteristics of anhydrous, you know, certainly, you know, you've got the physical disturbance of the applicator knifing that product in, and then you've got a very concentrated zone of application that certainly is going to, you know, essentially sterilize the soil in that area, and that effect is going to decrease as we move away from where that anhydrous was injected. You know, it's interesting. You know, soil biology is directly connected, however, to, you know, anhydrous, you know, being converted into eventually nitrate. And so it's, you know, it in some ways it's the return of soil of you know, particularly organisms associated with the nitrogen cycle and nitrification that, you know, would eventually drive that conversion of anhydrous to nitrate. And so from that standpoint, you know, if we're putting it out in the fall ahead of a spring planted crop, we don't necessarily want a rapid conversion of that anhydrous. So it's an interesting, you know, give and take there in terms of balancing anhydrous use and soil health.
All right. Well, there's another question, but I think it might be able to, we could answer that after Peter's, because I think it'd be also another more fit on what Peter's going to be talking about. So You should be able to share your screen now, Peter, so you can take over for your presentation.
Yep. You get into presenter mode here. Okay, are you hopefully seeing my slides, Craig?
Yep, you're good to go.
Okay, great. Well, so spend the next bit of time visiting and thinking about maybe thinking about the soil biology aspects of soil health and some of the interplay with cover crops. And so just kind of to review a bit on what Deanne talked about initially, as we think about some natural groupings of the measures of soil health. You know, we've got our chemical pools, so our available carbon, you know, nitrogen, phosphorus, you know, these could be, you know, any variety of tests that are out there, but, you know, I would certainly, you know, consider our traditional soil fertility tests, you know, that have a good set of data for correlation and calibration to yield as measures that we can utilize in thinking about soil health. And then the other aspect of this would be the physical properties that Deanne talked about. So aggregate stability, water infiltration, bulk density. And so, you know, as we step back a bit, the Soil Health Institute actually put together a table of what they considered tier 1 indicators. And these were methods that really were ready to go to the field, could be analyzed at scale within a soil testing facility, and related them to those kind of 3 core groups of chemical, physical, and biological. It's interesting as you look at biological and what was considered, you know, prime time ready. You know, we've really got 3, one of which I wouldn't even say is a soil test, but it's simply, you know, your crop yield and understanding, using the plant as the indicator of how your field and how your management has been impacting, you know, your soil health. And then, you know, the 2 biological measures really were tied to carbon mineralization and nitrogen mineralization. And so, you know, this has sparked quite a bit of research in finding and understanding methods that increase our understanding of soil health. And so we can think about these in really kind of three buckets. We can think about, you know, how big is the microbial community? You know, what's that size? You know, one of the simplest measures would be microbial biomass carbon. It's really been around since about the 1950s or 60s. You know, interestingly enough, folks have tried to connect this back to yield, and you know, results have been varying on that. Typically, it's done on fresh soil, so the ability to easily scale it into a production soil testing facility hasn't been there. Soil respiration, this would give a sense of the activity of the soil microbial community. There's been some advances made here in being able to scale measures of soil respiration. And then enzymes would be another activity measure. And so these would be enzymes directly connected to carbon, nitrogen, and phosphorus cycling. And so gives us an indication of the activity and the you know, potential rate of these enzymes for being involved in the nutrient cycling. And then, you know, we can go a step further and start diving into measures that look at the diversity of the microbial community. You know, this may be something like phospholipid fatty acid or PLFA. There are a couple commercial labs out there that offer this test as a you know, advanced measure of soil health. But again, the challenge is, as we look at these biological measures, they really have not been connected, or we've not been able to connect them back to any sort of prediction of yield. And so, within my research group, we've primarily been doing work at our Kansas Agricultural Watershed Project located here south of Manhattan, which is where this data has been generated from, but we've been looking at some other work across the state as well, trying to understand these different biological measures of soil health. And so to put these in context a bit, we also need to look at the chemical pools. And so, what we've seen here is by adding cover crops into a corn soybean rotation, we've seen, a significant, albeit small, change in total organic carbon. And we've also seen a change in the potassium permanganate or active carbon pool as well from adding cover crops. And so, that's been a consistent trend in each of the years or seasons. In case of the potassium permanganate, we've looked at that in spring and fall. And so, that tells us that certainly adding cover crops is doing something to the carbon component of our system and is affecting that positively. We've also similarly seen an increase in enzyme activity. And so beta-glucosaminidase is carbon and nitrogen cycling enzyme. Glucosidase is primarily a carbon cycling enzyme. And both of these enzymes have increased where we've had the presence of cover crops. Spring would be sampled, the soil was sampled just prior to terminating that cover crop and ahead of cash crop planting. So that really is picking up the immediate effect of cover crop. And, what I would say is this indicates that, the cover crops are putting, carbon-rich, root exudates into the ground. And then the fall is sampled after cash crop harvest. And so we're seeing, both an immediate effect as well as a lasting, longer term effect as indicated by the fall sampling in terms of these carbon and nitrogen cycling enzymes. The small panel here is change in AM fungi biomass. So again, this is getting at the size of the fungal community. And, in both the spring 18 and fall 18, we saw that cover crops, did affect the size of that community, increased those, and that was a consistent trend. And so this is where we bring PLFA in to dive a bit deeper into what's going on in our soil biological community in terms of the diversity. And interestingly enough, when we look at these communities on a percent of total basis, we're really not seeing significant differences as we look down these different groupings. So, seeing changes in the fungal, the bacterial communities, nothing's really jumping out as a major change here. But what the cover crop has done is it's increased the number of them. And so, this starts to shed some light on what's, going on in our soil biological communities. We can also, we've spent some time looking, this Kansas Agricultural Watershed Project has particularly had a focus on phosphorus management. And so we wanted to look at, how's microbial biomass phosphorus? Again, this is another black box measure of the size of the biological community. And you can see here where we haven't added any phosphorus, either with or without a cover crop, we've got a small amount of biomass is indicated by measuring the phosphorus, but in both our fall broadcast and our spring injected fertilizer management systems, we've increased the the size of the biological community compared to the no-P treatments. And so, is this that there's more available phosphorus for the microorganisms to incorporate into their tissue, or is this an increase in the size of the community? Again, this is where, we're working and more work needs to be done to understand all of these interactions. But certainly as we look here, we're not seeing differences in the statistical differences in the size of the microbial biomass P between our two fall broadcasts, in this case with cover crops compared to without cover crops. And, similarly, we're not seeing a difference in our spraying with injected phosphorus with or without cover crops. Although it's interesting to note here, that when we look at our two cover crop treatments, they're similar, but we do have a difference between our fall broadcast no cover crop and our spring injected cover crop. So, this does start to suggest that maybe there is some interplay between when that phosphorus fertilizer is added and the biological community, and that pattern continued in the fall as well. So the other thing that we can do is start connecting some of these biological measures back to our more traditional chemical measures. So in this case, we've found a pretty strong correlation between microbial biomass phosphorus and malic 3 phosphorus, which is the standard phosphorus measure from a fertility standpoint. Again, this is, I included this as it's an interesting finding, but again, this is another piece in the understanding of the linkages between biological measures, chemical measures, and ultimately yield that needs to be explored more. We've also looked at 3 enzymes associated with phosphorus cycling, and very similar to what we saw for the carbon and nitrogen enzymes, the presence of cover crops resulted in a significant increase in these phosphatase enzymes. And so, what does this all mean? What are some of the takeaways that we've come to after 6 years now of work at the Kansas Agricultural Watershed? Well, one thing that we've found was really pretty quickly in this study, we found as we converted the system from a full tillage system in 2014 to no-till, and so progressing through that early transition period, we found some pretty rapid stratification of our phosphorus treatments. And so both our fall broadcast and spring injected P management has resulted in phosphorus stratification. And so when we think about some of the implications for water quality, when we've got, a lot of P sitting right at the soil surface, that can present a problem and highlights an area that more research is needed. We've also, found, in this case, total carbon, total nitrogen, both we saw a statistically significant increase at the near surface with the cover crop addition compared to the no cover crop treatments. And similarly, that same stratification trend that we saw with our 2 P management additions, where we didn't add any P, we're seeing a consistent drawdown of that phosphorus. And so, when we look at the malic 3P, again, this one we're not seeing a strong, we're not seeing a major difference with and without cover crops, no significant difference there at the surface, but we do have that stratification. And so, what does this bring us to? Well, certainly as we look at some of those increases in the biological activity at this site associated with the addition of cover crops. We think that is a connection to, why we've started to measure these increases in dissolved phosphorus loss. And so, consistently throughout the study, we've seen, increased dissolved phosphorus loss in the presence of cover crops compared to the no cover crop treatments. And, interestingly, our total phosphorus, we tend to not measure a difference between cover crop and no cover crop, but what we are seeing is that shift in the form. So shifting from particulate P loss to dissolved phosphorus loss. And so, some other pieces that come into play here that really connect back to the physical, the chemical, and the biological. We've also measured that while we're not changing the total amount of runoff by adding cover crops into the system, we're changing how long that water stays in the system. And so, that means that, so here the brown bar, we've got a quicker peak runoff event, and, it ends sooner. Whereas where we've got the cover crop, we've documented a delay in the peak runoff, a lower peak flow rate, and then a longer tail here, so the runoff event is lasting longer. So when you take that, connect it with, enrichment of phosphorus at the near surface, and then connect that with the higher microbial biomass and activity, I think these are all factors that ultimately contribute to the higher dissolved phosphorus runoff that we've seen. And so, this just highlights that, as we think about this, certainly, we can improve the biological soil health through the addition of cover crops. Converting to no-till would certainly have a similar effect. Again, it's less disturbance, so you're not destroying the habitat for the microorganisms. Our cover crops, I didn't show it, but we've documented decreases in the soil erosion beyond what we were measuring for no-till alone. But we do need to there's a bit of a cautionary tale here that we do need to think about, some of the unintended consequences, and that's dissolved P runoff losses. So, it's great that we've improved the biological health, and I think that is the direction that we need to be looking, but that brings up that we need to rethink, phosphorus fertility maybe. And so, what we're doing now is we've changed our treatment structure, and so we've got one that will be managed at a sufficiency level rather than a build and maintain level. And so we'll be able to see how does that affect the soil biology, but also how does that affect phosphorus loss from the system. So, jumping, so just a few final thoughts here. Certainly, as we think about conservation management, and this really leads into the second part of my presentation, we need to think about what are the specific goals that we want to achieve. Certainly from the soil health aspect, the biological piece particularly is a fairly young science, and we need more research across more environments, and then careful interpretation of the data, so that we hopefully can get to a point that we can connect that to like we have done with Malic 3 for phosphorus fertility recommendations. Connect that to, improved crop production. And so, the work at the Kansas Agricultural Watershed has had many funding sources that we thank for letting us do this. And then just jump over here and spend the time that I've got left, thinking about cover crop selection, because as some of the first questions came up, certainly we've got to think about our environment. We've got to think about, you know, what makes sense. And there are some great extension resources out there. One is the Cover Crop Field Guide. Deanne and I were co-authors on this with folks from all over the North Central region. And if there's interest in a copy of this book, let Craig know and we can get some shipped out to the Midway District. But, you know, and there was a question in the chat box just as I started, you know, kind of leading into, you know, a discussion about, you know, how do you make a choice to add cover crops and then even further to select cover crops. And I think it comes back to the simple question, what's your objective? You know, I view this as a very personal matter for each operator, but, you know, what is a given operation's, you know, specific, you know, goals? You know, is it building residue? Is it reducing nitrogen leaching? Is it weed control? You know, is it reducing soil loss? The list goes on, but all of those pieces really do factor into deciding, you know, what is the right cover crop, when is the right time to add a cover crop into your crop rotation. And then, you know, some other factors, you know, what are you willing to spend? You know, what seed costs are you willing to absorb? You know, if there is a grazing component, are you gonna add a little fertilizer to increase that biomass production? And how does that factor into you know, potential pounds of beef? And that's all I'm gonna say since Jamie Lynn is up next. You know, what equipment do you have available? And, you know, it's a great point. You know, are you willing to spend some of your soil moisture? You know, because if you plant that cover crop and it turns off dry, you know, we saw that here at one of our on-farm projects in 2017, where, you know, we were dry in the fall, we went ahead and planted that cover crop, and, you know, it utilized, you know, moisture, you know, and impacted the 2018 cash crop. And so, you know, that you know, are you willing to spend, you know, some of your soil moisture to grow a cover crop? And, you know, one of the resources that we have available to help, you know, with figuring out cover crop selection is the Midwest Cover Crop Council Selector Tool. And so I am going to stop my share of the PowerPoint presentation, and we're going to just walk through the website version of this and spend a little time looking at some of the factors that go into play here. So, all right, so we should be on the web page, and so you see my cursor on the row crop tool button, Craig?
Yep.
Perfect. So we're going to go in here. This website is housed at Michigan State University, but 5 years ago now, Kansas was added to the selector tool. So we're going to go in and select Kansas. And then this is done by county. And the reason that you need to add your county is we have factored temperature gradients, freeze dates into this decision tool. And so you want to go down and pull up your appropriate county. And so we'll find Russell right there. And then the next thing is it starts off with what's a goal? You know, is it erosion? Is it mechanical forage harvest? Is it for good grazing? You know, is it, you know, nitrogen scavenging? So let's just go ahead and we'll do nitrogen scavenging. We can add another goal. So let's just go ahead and we'll add erosion fighter. So we can go show current cash crop options, select a cash crop. Let's do, we're going to start with a corn soybean rotation, and then we'll jump back and do a wheat sorghum rotation, and just so that folks can see some of the differences. So let's do corn grain. I am going to say April 25th. Does that seem reasonable, Craig?
Yeah, that's
harvest date, we'll go, let's go October 15th. Show drainage options, we're gonna go well drained, no flooding. So we're gonna, and we'll find cover crops. And so the tool, there's a whole database that was built behind this, the tool, and it we can see here, because of, I put a later corn harvest date of October 15th. The area that is grayed out, those are, a cover crop window that wouldn't work. So what we're looking at is cover crops that have a green bar outside of that. So we can see here, cereal rye would be an option, winter barley, winter triticale, winter wheat would jump up as options for planting in the fall. Those would be grasses. Given the parameters that were put in here, when we look at the legumes, those aren't, we're not seeing great options there. We're not seeing great options for brassicas. We're just outside of that window where we would expect enough growth to make sense. Now, what does pop up on the front side would be, some spring planting options. And so this, you could be playing the moisture game. Maybe you weren't sure what your moisture was going to be in the fall, but it's turned out to, looks like it's going to be a wet spring. Looks like there's going to be sufficient moisture. So this highlights some of the spring options that would be available. Spring triticale, spring oats, annual rye. We can see that we've got some legume options. Again, factors in, are we going to get a lot of growth? Is it going to be enough growth that makes sense for our given crop rotation? Maybe, maybe not. But let's say that it's, you're in a wheat corn rotation or a wheat sorghum rotation. You've harvested that wheat in the fall. You harvested that. Well, let me jump back here. Let me jump back and let's put wheat in actually and see how it looks. So go back to Kansas. Russell, nitrogen scavenger, erosion fighter. Cash crop is going to be wheat. Planting date will be September 15th. Harvest date may have found a bug. All right, well, let's step back here. Well. Huh. Well, we'll see if this works. Okay, so we're going to have to use our imagination here. I will get with the programmers after this. That's always the challenge of a live demonstration. But let's imagine that we have planted our wheat crop, and we know that we're going to be grayed out through mid-June to even mid-July, depending on the year. So we draw a line down through all of these options. What we can see here is we start to see some different options that open up. Because we've got that late summer window, sorghum Sudan grass, forage sorghum, pearl millet come up as options now. As well as our later planted, more traditional winter cover crops. So cereal rye, winter barley, winter triticale, winter wheat. These all come up as options that would work after wheat planting. When we look at the brassicas here, grazing radish, annual ryegrass here. And so you might be wondering, what are some of these numbers that show up on the front here? Well, that's really their rating for our different decision factors that we plugged in. So in the case of winter cereal rye, it's got an excellent rating for nitrogen scavenging and erosion fighter. If we look at the forage brassica, excellent for nitrogen scavenging, but it's good, but it's not the best that's out there from an erosion fighter standpoint. And so it's going to put our best choices up top, and then as we go down, here we can see, our millets, they got a good rating from nitrogen scavenging standpoint, a little better rating for erosion fighting. And then we go down here and you can see now we're starting to get into the one, for, poor for nitrogen scavenging, well, fair for nitrogen scavenging, kind of a 3, very good rating for erosion fighting. We can see that, it's sorted them where we've got, some of our less desirable options would be all the way down at the bottom here. And so, this is a freely available tool for anybody that's interested. We invite everybody to use it and, look at, your cover crop options. We've got a few mixes plugged in here, although, another way to think about it is, look at, based on your desired goals, look at some options that would make sense to build or evaluate mixes that you're looking to purchase. And so with that, I will stop sharing, and I'll just say, I thank everybody for their time today, and I'll be happy to take any questions.
Good. Okay, so it looks like you answered Carlos's question of what he had. Going back to the soil health and the nutrient side, Peter, how much does a producer looking at, planting cover crops need to look at the carbon to nitrogen ratio of, what they're going to be growing? Because I know sometimes that can play a big factor in, potentially tying up nutrients, especially if you get too high of a carbon mix.
Yeah. And so, I've worked with Craig Rosenbaum since I got here. And so he's had the long-term cover crop project going here in Manhattan. It's been a wheat, sorghum, soybean rotation. And, we did see that, where we had a high biomass, high carbon to nitrogen ratio cover crop. In the case of that project, it was sorghum Sudan grass. Probably not the best choice to follow with sorghum the next year, but we were looking for that, that scenario with a high carbon to nitrogen ratio cover crop, and that required about 30 to 40 additional units of nitrogen to achieve the same sorghum yield as sorghum that followed either a late maturing soybean that was rolled as a low cost, nitrogen fixing summer cover crop, or winter cover crops that included daikon radish, or as a non-legume, or crimson clover, or red clover, depending on the year. And so certainly those high C to N ratio cover crops, there is a nutrient cost that producers need to be aware of. I'm familiar with, through 4 cycles of that crop rotation. So 1 out of 3 years, we would have had that high CDN ratio cover crop. So not every year, but through 4 cycles, we were still needing to add that additional nitrogen. Now, if somebody was going to plant cover crops every year, would there eventually be a tipping point, and you wouldn't need to you wouldn't need to continue to add additional nitrogen? I haven't seen any published data to that, but maybe.
I was going to say, because I think, well, I follow some, stuff across the whole United States on cover crops, but I know there's some claims that, over time that you can actually reduce your fertilizer that you apply, like nitrogen and phosphorus. I was going to ask you if there is any long-term studies that you've seen that show that correlation with cover crops to reduce fertilizer.
Yeah, I think our certainly what we're finding from the watershed, the Kansas Agricultural Watershed Project, from a phosphorus standpoint, that does suggest, particularly with the pronounced stratification that we've seen with the build and maintain recommendation, that there may be an opportunity to make some changes there. Is that cover crop specific? I would say no. That stratification, I think, is inherent with no-till production. And so if a producer's in a area where we've got phosphorus runoff concerns, we need to be cautious and think about our phosphorus management. Perhaps look at a sufficiency-based approach where we're more like nitrogen management, where we're spoon feeding that phosphorus to the crop as it's needed. And I think there's at least early evidence that we can reduce our phosphorus application rate. But again, I don't think that is necessarily attributed to the cover crop, it certainly is a factor that's affecting the phosphorus dynamics. In terms of nitrogen, you know, that gets a bit more complicated. Deanna and I are actually a part of a large multi-state project that's going to try to answer some of the questions around nitrogen. You know, certainly if we are scavenging nitrogen out of the system, preventing that from leaching out of the bottom, you know, we're retaining that nitrogen, and then as the crop residue decomposes, you know, it should be available for that next crop. The timing is a bit of the unknown, when it will become available, you know, so, you know, nitrogen, you know, as well as phosphorus, these nutrient dynamic questions, you know, need more work, you know, and you know, do require, you know, long-term research studies, which, you know, can be a bit of a challenge from a university standpoint.
Well, does anybody else have any questions for Peter? Said, if not, we can get ready to move on to Jamie Lynn.
All right. Well, thank you, everybody. Enjoyed the opportunity to visit with you today. And
Yeah, thank you, Peter. Jamie Lynn, are you there? Can't hear you for some reason.
How about now?
There you go.
Yeah, so glad we're doing Zoom, so nobody can see that from about my chest down, I am covered in cattle manure. I've been out putting cedars in cows this morning, so. And I know I am last on the list, so I will hopefully not bore you too much as we go through some of this stuff. So for those of you who do not know who I am, I'm Dr. Jamie Lynn Farney, and I'm a beef systems specialist with Kansas State. I'm housed at the Southeast Research and Extension Center. So I kind of got started looking at these cover crops, aka annual forages, as a forage source for cattle when I came into Kansas. And, you know, I grew up in New Mexico. I saw all these green, beautiful, lush pastures, you know, because to me, anything could be a pasture because you could put livestock on it with a little bit of fencing, etc., that were all of a sudden sprayed and killed. And I'm like, oh no, Lord, they know not what they do. Because, you know, coming from New Mexico, if it's green, you better be grazing it. So I found out what cover crops were. And I didn't hear Peter and Deanne's talks, but I have followed them many a time, and they do a great job setting up what they are and the benefits of it in the below ground portion especially. So I want to talk about the above ground part and how we can utilize cattle within our cropping systems. Now, why might we be interested in doing that? Well, one of the quickest ways to return an economic return back into your operation is to incorporate cattle into the system. Now, make sure you're hearing me say this. Just because you are grazing cattle on it does not mean you're going to make money on your cattle. But if you appropriately do your budgeting enterprises, the cattle should pay at least for the seed and some other rent on that piece of property. So your grain enterprise should be making some money. Now, as Peter had already, you know, I did see he was showing you the Midwest cover crop decision tool. There's a huge list of potential cover crops or annual forages that we can put out there for cover crop benefits, but also from a cattle perspective. I love this image that came from NRCS that shows the cover crop chart. It's essentially a periodic table listing all the different plant species that could be potentially used as a cover crop. Well, not necessarily all of them would be great as a livestock forage. So trying to determine which plants to select becomes important within your operation. And because there is that long list of things, long list of plants that you could put, it's great that there is no one size fits all. You know, you can plant more drought hardy type of plants, or, you know, less drought susceptible plants in western Kansas that we might not necessarily do here in the eastern side. And, you know, like Peter showed you, you could set up your specific goals for your operation. And that is the beauty of using annual forages, is you can develop what is going to be the most beneficial for your specific operation. So why would we look at integrating crop and livestock systems? I cannot say it any better than a quote I'd found out of Allen and others. It encouraged sustainable farming and generates positive interactions between crop and livestock with environmental and economic benefits. Do any of you have an issue with that statement? Us in agriculture, that is what we do. We always want to be able to have something that we can pass on to the next generation. That is some sustainable farming. We take care of our land. We're good stewards of our environment. And of course, we still have to make a living at it. But what are some specific benefits that multiple different researchers around the country have found? When you integrate cattle within your livestock or cattle within your cropping system, it reduces your risk of raising a single product. So that can be looked at from a multiple different directions. One thing that I immediately think of, because it's still burned in my brain, what happened in, I think it'd be about 2012, a little earlier, corn was so high. You got paid a bunch for corn. And as such, the guys who had cattle weren't making a whole lot of money. Yeah, even though the cattle were selling for a lot of money at the time, your net return was actually very small. So that's what typically happens in the cattle and the grain crop markets. When one net return is really high, and you know, when cattle are making a whole lot of money, it's usually when corn is cheap. And so when you have both of those, you're more likely to maintain a static economic return to your operation. Also, you know, just like Peter kind of mentioned, what happens if you have a drought and your corn's not making anything? You just got a bunch of corn, earless corn standing out there. What are you going to do? Well, cattle are wonderful salvagers of failed crops. So that's another deal that you can put in there. Putting cattle into a cropping system actually increases your water infiltration rate. Part of that is, especially, you know, with these annual forages, if you have something growing, oftentimes that's one of the components that increases. That's what I've read. Reduce your soil erosion and manure. It potentially could help you with your within farm nutrient cycling. Maybe be able to put out less synthetic fertilizers. And there's actually quite a few long-term studies out of Western Kansas where they've been adding feedlot manure out into crop ground. And that has been the quickest way that they've been able to increase organic matter in some of those fields. Really interesting publication about that. Now, I do know, you know, I can't just say, oh, cattle manure is the be all, do all, the best thing that's ever out there in regards to a fertilizer. There's a couple of issues with it, you know, availability, it takes a little more time to get incorporated, etc. And we just haven't quite been able to train cattle to urinate and defecate on every square inch of a field. So once we did that, then we might have the perfect animal or the perfect system in place. Now, there's not any, or I'm not saying there's no issues with putting cattle into our cropping systems. And I want to rearrange this because we actually had a survey that we sent out to producers here in Kansas. And we asked, what is your #1 limitation for putting cattle into your crop ground? Well, the number one is water. A lot of our crop fields do not have a permanent water source. And so you have to determine, you know, whether it's economically feasible to haul water. The other thing is when we went big fields, all the fences got taken out. So you have to worry about fencing as well and keeping your cattle in. Compaction, that's actually been going down. There's getting to be more and more research out there that shows with some intelligent grazing, cattle lead to very little compaction. And in Kansas, we really don't have near as many compaction issues because of our freeze-thaw cycles, you know, our wet-dry cycles. That ground does really expand. When we do see some compaction, it occurs in that top 1 inch is about it. So you can work with that. And just due to the fact that I don't have enough time, I'm not going to talk about toxicities, but there's actually quite a few of these annual forages that could kill your cattle. And I should put the link in, but I do have a publication on our K-State library, potentially toxic forage crops. And so it talks about all of the annual forages, which ones could kill your cattle, which ones you can manage for, and which ones are just rolling the dice that your cattle might be susceptible to death due to consuming them. So those are all things you have to think about from the annual forages. So when we were looking at, you know, I briefly had already talked about the quickest way to get an economic return is to put cattle into your cover crops. Well, it's starting to be a little bit of a dated publication now, but it's one of the first ones that looked at integration of cattle within cropping systems, but also looked at grazing a winter cover crop, which is the second from the last row, a summer cover crop, which is the last column. And then they also looked at tillage, whether you were conventionally tilled, which is represented by CT, or no-till ground represented by NT. And they grazed pairs out this, you know, cow-calf pairs. When there's a lot of numbers, so I just really want you to look and see that there's no negatives on the gain. Traditionally, our cows lose weight while they've got a calf at side. However, on either of these cover crops, they gain weight. The other thing that I really found interesting from this publication is look at the numbers that are in green that have an asterisk. Those were significantly different gains observed between conventionally tilled and no-till ground. And as you look through all of those numbers, cattle on no-till pastures or no-till fields had higher gains, greater gains per acre, better gains per animal than those on conventional till. So I thought that was kind of interesting. And I first thought, okay, you know, they're not tilling up all that dry residue above ground. Well, when you looked at total biomass, dry matter biomass, there really wasn't a difference between conventional till and no-till on this. But it really came down to the soil structure. And, you know, Deanne can explain this so much better than I can. But that no-till soil structure is just firmer, and the cattle don't have to expend as much energy walking across the no-till field. You know, when you walk through mud, how many calories are you burning? It's tough walking through mud. It's much more heavy activity to do that versus walking on cement. So that's kind of, you know, my closest cattle analogy I can come up with to be, you know, a cattle producer's mentality to understand soil. Once again, a lot of numbers, but just look at the last row, that net or last column, net return over variable cost. Everything that's negative was just planting a cover crop without grazing. Everything that had a positive net return was just adding cattle into the system. So I think I said it probably 4 or 5 times now. It's kind of an important point. Adding cattle into your system is the quickest way to recoup the cost of your cover crops. What about some of this Kansas data? What have we seen? Well, I have just a 1-year study. It was done in Linden, and we had a fescue pasture versus a cover crop cocktail blend. So we had 8 different things in our cover crop blend, and this is for a winter grazer. And I'm so sorry. No, that's actually correct. We had wheat. We planted a cover crop. We harvested the field for wheat grain, planted a cover crop, grazed it, and then followed it with season-long beans. And we turned out heifers. The cattle that were on the cover crop gained nearly 0.4 of a pound more average daily gain than those on the fescue. And that was even feeding those cattle on fescue more grain than we were offering to those on the cover crop blend. And the reason we were doing that is the producer, he really wanted to push those cattle. He ideally wanted at least 2.5 average daily gain. So we were feeding them in addition to what was out there. But even with the feeding, and this is, once again, a lot of numbers, but the bottom line was we had a $70 per head net return improvement advantage to the cattle grazing the covers as compared to grazing the fescue over the winter. Now, what else are some things we need to know about covers as an annual forage? Huge list, but what do we want to plant? Well, we know that in our perennial systems, grasses that you don't have to replant every year, diversity is the best, and especially in regards to soil health and cattle performance. The more plant species out there, the better your cattle do. And that especially becomes evident in some of our tame grasses like fescue and Bermuda, brome, etc. Now, if you already have a diverse perennial pasture, there's one study where they put some annuals into like a native range that already had a bunch of different plant species. And they found that adding those additional annuals into it did not improve any measures of cattle performance. So if you already have a diverse perennial pasture, you can't make any changes in God's perfection already. Now, what do we know about the annuals? And this is where I think is really interesting, because annuals are a completely different kind of plant than your perennials are. And as such, what grows, cattle performance, etc., I think are completely different with our perennials versus our annuals. And there's actually very few head-to-head studies looking at cattle on just a grass-only annual versus a grass plus some other plant species, your legumes or broadleaves. The few that I found, and granted, these are still multiple different species of grasses, not necessarily like a grass and a legume, but a Florida study showed that a triticale and a ryegrass did not improve cattle gains. And that addition of the triticale was a lot more expensive. In a study out of Texas, an oat ryegrass mixture had similar gains as cattle that were on a ryegrass oat mixture. And I actually did a head-to-head comparison where I had some dual-purpose wheat where we added radish in to break up some compaction and grazed or not. Statistically, they are not different as of yet. I only have 2 years of grazing data, need a few more years. Statistically, if it's less than a 0.10, we say they are different, 90% or 90% confident they are different. And this shows you some of the huge variability, because when you look at our raw averages, the cattle on the wheat plus radish gained 0.5 pound less average daily gain. And it still wasn't significant. So like I said, we need more years. But we did see a drastic reduction in our wheat grain yield when we incorporated the radishes into this dual purpose system. Now, what about our hay quality? Now, these annual forages, very, very high quality. These are some winter forages that I helped collect some samples on. You can look at our protein and energy values are anywhere between 10 to 30% higher with these annual forages as compared to some of these perennials. So when we look at really good high quality, you know, I saw that the title was 101, so I figured I should throw in some rules of thumb to kind of help you if you've never grazed your annual forages before. So for your winter stockpiled forages, if you are looking at grazing them, typically we get about 150 pounds per acre of dry matter for each inch of growth. So if you had, say, 6-inch rye out there, there's 900 pounds of forage above ground. Now, on these annual forages, we graze them a little harder than we do our perennials. So if you utilize 50% of it, that's about 450 pounds per acre. If you have 500-pound calves out there, that's 6 inches of rye, gives you enough grazing forage for about 50 days. Sorry, the chat box popped up and I got lost for a second there. So I'm sure somebody had talked about the broad categories of your cover crops earlier, but you know, the grasses are our most predominant, and I'll show you in a little bit, our most highly selected from our cattle perspective. Our broadleaves, our brassicas, are also a very, very popular cover crop to put in for most of our cattle producers. I have a love-hate relationship with brassicas. And when I throw out the word brassica, that's turnip, radish, rapeseed, kale, canola. Those are some examples of brassicas. They are very highly productive if you get rain. If you don't have rain, they don't do great. And a very high quality forage. Actually, from a nutritional standpoint, they are the same energy value as corn with 4 times more protein. So that is a really, really good feed out there. Now comes the hate part of them. They're 80% water. So your cattle have to eat a lot of them to feel full, to get enough actual dry matter that they need. And you never walk behind cattle that are on very high, a field with a lot of brassicas. It's just nothing but liquid green coming out the back end. I am sorry, it is not advancing. Hold on one second. There we go. The other part that makes me not really love the brassicas is there's certain sets of cattle that really, really do not like the brassicas. If your calves weigh less than about 700 pounds, they'll almost starve before they'll want to eat those brassicas. Cows, on the other hand, they're a little less selective, and the more times they've been exposed to the brassicas, the sooner they start consuming them. But it really does you no good having that corn energy, extra protein if the cattle don't eat it. And we have seen that that actually occurs in several different research projects. Now, the brassicas, they have different palatability based on whether there's been a freeze or not. Now, I always thought, oh, you know, because I'm one of those crazy people. I went out and ate some of the turnips in the field pre and post freeze. And after a freeze, even though they kind of stunk, they were way sweeter after a freeze than they were pre-freeze. So I thought, hey, I figured out why my cattle really like eating these turnips after a freeze a lot better, because there's a higher sugar content. Well, you look at quality, and you specifically look at the sugar concentrations, they're not different pre and post freeze. What becomes different is this chemical, or this, it's a chemical called glucosinolate. That's what causes the spicy in your horseradish. It's very bitter for cattle. And so it's at a very high level pre-freeze, and after a freeze, it reduces drastically. So when that bitter goes away, you know, that bitter's so high it masks the really good sweet of the turnips. As that glucosinolate goes down, that sweet flavor becomes more prominent. And then, so that's why after a freeze, you'll kind of see those cattle just go, I mean, they look like hogs at a feed bunk, just going after them like crazy, pulling them out of the ground, swallowing them whole, etc. But pre-freeze, those 700-pound calves, I've had a couple different producers, those calves almost starved to death because they refused to eat those brassicas pre-freeze. Now, legumes, you know, they've talked about that quite a bit. They've been incorporated into mixes for nitrogen fixation. So far, I have yet to, and a lot of other folks I visited with, have yet to be able to grow legumes in our winter mixtures very successfully, minus hairy vetch. Hairy vetch does pretty good. I stay away from hairy vetch if you are grazing it with cows. Mainly because hairy vetch is one of those plants that has a potential toxicity that is very, very toxic to your animals. It maybe impacts 1% of the entire cattle in the world, but when it impacts your herd, you're looking at 20% death loss, just instantly. So the hairy vetch toxicosis, it's like an allergy. That's the best thing I can come up with. Certain cattle become allergic to it. And the more times they are exposed to it, that's when you see it. You might not see it, you know, the cow's grazing it the first year or the second year. It might be year 5 that all of a sudden your cattle are just become allergic to the hairy vetch. Black-hided cattle, black-hided horses, black-faced sheep tend to be more susceptible to hairy vetch toxicosis. Younger calves, it really doesn't seem to be that big of an issue. But all of the research out there shows that when it hits your ranch, you're looking at 20% death loss is what typically happens. So I stay away from hairy vetch just because of that, because we can't test for the specific toxin. We can't test to see which animals have the sensitivity to it. So I can't in good conscience tell you, that's perfectly fine, go ahead and turn out. And then you have 20% of your cow herd die. The other thing from our winter legumes that I question, typically legumes are included in cattle diets to add nitrogen or add crude protein. All of these winter annuals offer way more protein than your cattle need. And I even wonder if they're being offered a high enough amount of protein, if we don't add an extra amount of energy to it, that we may lead to some potential kidney issues and long-term issues in some of our cattle from overabundance of protein intake. And I've only found one study that actually looked at that addition of those legumes into our winter grass, the ryegrass. It was a dairy cow study, but when they added the clovers into ryegrass, they did not improve any measures of dairy production. No improvement in milk yield, milk fat, or protein. And legumes are the most expensive single component of your seed mixture when you're looking to put in there. So if it's not growing and your cattle don't need it, and remember, this is me just talking from the cattle side, I'd save money and not put in my winter legumes. And, you know, that's actually me out in a field doing some spot checking to see how much legumes grew or not. And I had some of these blends, and whether a legume emerged or not, we did not impact production, any measures of quality of our cover crop blends. So we are, I have a lot of information, so I'm kind of picking and choosing what to show. The other thing about the winter legumes, and you can see from here, our winter legumes just do not put in very much appreciable biomass. especially when they're in mixtures with a grass or a brassica. Now, when we're talking about some of our warm seasons, we do see a little bit different from the legume perspective on our warm season. Our warm season legumes can actually compete pretty decent with some of our grass species. This just shows you I had some brassicas, which were mustards or collards, our broadleafs, which were like okra, safflower, grass species, and then our legumes that we were looking at. And this is just average of the, based on category. Our grass legume and our broadleafs, well, and in this study, our fallow did just as good as everything else, but it had crabgrass is what was growing. And from my cattle perspective, I love crabgrass. That's a great cattle feed. So that wasn't too bad for me having my fallow be mostly crabgrass. But the brassicas, our summer brassicas, don't do quite as well especially as compared to our legumes. And these are 3 species cover crop blends, or one or two different species. A lot of information, a lot of numbers here, and I will give both Craig and Clint these slides so you can really sit and process these at a later date. But the green represents the portion of the dry matter that came from grass. The brown the dark brown is from our broadleaves, and the gray is our legumes. Now, in this study, we did a spring pea is what they had given me. Spring pea does not work for a summer legume. So put that down. Dr. Farney learned that. Do not plant a spring pea if you want any appreciable amount of legume. Go with something like a sun hemp or a cowpea. You'll be much happier with those. So this summer I had, once again, 17 different cover crop blends, and I either harvested it as a grazable forage, as a silage, or as a hay. And we were looking at quality, quantity, as well as what is our subsequent wheat yield off of these. It's a lot of different information there. And this is what it looked like out in those different fields. And we had we had a lot of rain early summer, none at the end of the summer where our location was. So we had really good stand emergence and pretty good numbers at the beginning of the year. And then our biomasses went down. But when we looked at, and I still need to add in I have one more grazing event and one more hay event in our biomass. But when you look at the number of plant species in our mixture, this was the first time I have ever found that a multi-species mixture resulted in greater biomass production than just a grass only. That's in my green bars over here. One species was like our grass only. 2 was a grass with something else. 3 was like a grass with a broadleaf and a legume. And then the all was, I just mixed everything together. Typically, I find that most, especially in my winter projects, that when you add anything in with your grass, you have less biomass production. Unless it's just a grass and a brassica. And I am sorry, I forgot to say this. Back on my love-hate relationship with my brassicas. If you are going to graze a winter grass with brassica blend and you're going to have calves under 700 pounds, 1 pound of brassica seed is all you put out there. If you go more than that, they outcompete all your grasses and your calf gains are not near as good. If you have cows, I'd maybe go up to 2 pounds, but I don't go over that because that just they just outcompete anything else if you have any moisture. So I have very little time left, so I'm going to hit a few more high points. I had briefly touched on this before, but cattle find they really like grass species the best. And I had some selectivity, or what cattle consumed. When we looked at this Graza forage radish, and that's a specific brand of forage radish that's actually low glucosinolate concentration, we find that they almost want to eat it as much as they did barley. And most of my other brassicas, the turnip, collard, rapeseed, mustard, pre-freeze, cattle just did not like them at all. But when we look at post-freeze, once again, oats and barley are a grass species. Cattle more highly select them. But the part that I thought was really interesting was after a freeze, the rapeseed became much more highly selected as compared to what it was pre-freeze. It actually fell in this middle selectivity level as compared to being last the pre-freeze time. So, depending on when you plan on grazing will make some differences on what you choose to plant. Now, for when we're looking at specifically how to use it for our cattle, you have to think about what category of animals you have turned out. So I have in the green line the daily energy requirements for a fall calving cow by month. This is how many calories, megacalories, she needs to eat in a day. And in the yellow line is a spring calving cow. Now, all of the lines up in the upper right-hand corner, that is if you just turn your cows out and allow them to continuously graze any of these winter annuals, that's how many calories of intake those cows would have. You can see that the calories in are above what the cows need. So when calories in are higher than calorie needed or output, what happens? You put on weight. That could be good if you had thin cows that you need to put weight on. However, if your cows are already in good shape, especially if they're like a dry preg, they don't want a lot of weight on them, because too much body condition is an issue, is as much of an issue as having too thin of a cow. And, if you're putting too much weight on your cows, too much condition on your cows, it's an inefficiency in your production system. You could actually put more animals and graze it harder and not put as much fat on and be able to have a higher return on your investment. So how do we manage for these annual forages, especially these winter annual forages, to more appropriately meet cow requirements? So one of them is limit grazing, and another one that I've coined a combination paddock. I don't know anything else. It's what I've done. So in regards to short-term grazing or limit grazing, Oklahoma State has been one of the, and Nebraska have led the charge on looking at this. So the folks at Oklahoma State, what they've done is they turn out their cows 3 times a week for 4 hours on each of those days on their high protein, high energy annual forage. They use wheat because it's Oklahoma. We can use anything else, oats, barley, wheat, etc. And then the rest of the time, those cows are out on dormant native range. So just allowing those cows that 12 total hours over the week access to that annual forage. These were fall calving cows. They still put on some weight with these cows, but those cows were in great condition, and those calves gained more than the pairs that were out on dormant native range and being heavily supplemented. The folks in Nebraska, they get to cheat a little bit because, a lot of their land is irrigated. So they'll put a hot fence on the irrigation pivot and set it up to move X number of feet every day. And they've calculated out how many point acres a cow needs in one day just to meet her maintenance requirements. So then that's how they work on limit grazing their cows. We can do the same thing just by moving, kind of strip grazing across some of these paddocks. Now, if you're not one to put that much labor into it, you know, and that's what, there's a lot of labor moving your cows on and off pastures. That's where I came up with the combination paddock. And this is what my own personal cow herd does. We have a portion of the pasture field that's corner milo stalks. And then the next portion is our winter annual. Oftentimes it's wheat that we do dual purpose wheat with. Other things is just planting the corners of your circle if you happen to have irrigated land, putting those into your high quality forage and then grazing your stalks. And you fence off all of it and let the cattle have access to both that high quality forage and that low quality residue. Cattle do consume both. You might be sitting there going, she doesn't know what she's doing. They're just going to camp out and just demolish my wheat and I'm going to have nothing. So I actually put GPS collars on my cows to see where they were, what they were eating. And in the dark gray bands, that's where we had wheat strips. And the light bands is where there was corn stalk or milo residue. I can't remember exactly which field I took this snapshot of, but those yellow dots is where one cow was every 30 minutes, 24 hours a day for the 90 days she was out on that area. You can see it's about 50-50. They spend equal amount of time eating off of both of those. And when you actually watch how the cattle consume, they spend more time actually eating in the stalks, and they really just go out and eat out of the wheat every once in a while. It amazed me how well they kind of balanced their own diet. Outside of this heifer, so I had only 4 collars, and I've got Charolais and Angus. So I had an old Charolais cow, a young Charolais heifer, an old Angus cow, Charolais or Angus heifer, just to see if there was difference in breed and age. Well, my Angus heifer, you can see, she kind of camped on that line between the wheat and the stalks and didn't move off of it very much. I thought, well, she didn't graze very good. And somebody's like, nah, that's just an efficient cow. She spent less time walking, more time eating. And sure enough, she was the fattest heifer we had. So if you're wanting to do that combination, how much do you need of each? So I did the math. This is for a 1,400 pound dry pregnant, if you have a dry pregnant cow. If you have a 130 bushel corn yield, that's what I use for my calculations. You need close to 2 acres of stalks and a little over an acre of your cocktail or your annual forage, winter annual forage. And that provides you enough grazing to meet your cow requirements for 90 days. For your fall calving cows, they need just a little more energy and protein. So you go up to about 1.5 acres of your annual forage or cocktail, and then a little over 2 acres of the stalks. Once again, I said, if you just want to build fence once, just turn your cows out, this is the way that you can possibly do that. Now for your calves, if you're grazing stocker or growing animals, gains are all over the board on these annual forages. There's a study out in Nebraska that had 10 different studies summarized, and they had gains anywhere from 0.8 of a pound all the way up to 2.3 pounds of average daily gain. And even in back-to-back years where they had same blends planted out there, one year the calves gained 2.3 and the other 1.3. You know, and part of that is due to what was growing based off of weather events. And one of those deals, and my studies also find this as well, especially with our brassicas. If you have a wet fall, you're going to have a lot more brassica biomass out there. And it seems like the more brassica out there, those calves under 700 pounds just do not gain as well on them. And this is summarized from Minnesota, but they, for purpose of time, look at the yellow set. They had cattle on what was about a 70% turnip, 30% oat blend. They only had a 1.5 average daily gain versus the 30% turnip, 70% oat. They had nearly 2.25 average daily gain. So the more brassica that's out there, which is surprising because like I said, they got the energy of corn and 3 times or 4 times the protein of corn. The more that's out there, the less their cattle gain is. So I like to, like I said, if you're grazing growing calves, 1 pound of brassica is about all you can put out. The folks at Nebraska find that about 1 pound of the brassica seed equates to about, you can take out about 20 pounds of your cool season annual seed and still have the same amount of biomass production. So you can use that in your calculations of mixtures and blends. Oh, here we go. Here was my actual numbers to show you my reduction in calf gain with adding the radish. And then on my wheat yield on the right-hand side, with the yellow bars and radish, I mean, that was nearly a 5 bushel reduction in wheat yield with the addition of a radish. Cattle did not impact it. So, and I'm also, we're in 1 year of study so far, but I have a producer I'm working with that's closer to you guys' area, that he's looking at converting 160 acres of his current cropland into a year-long annual forage system. And just this summer, in that top image there, he was able to support 110 cows from May to mid-September on 160 acres of crop ground. He had some sorghum sudan, crabgrass, some teff that did some rotational grazing, strip grazing, some haying off of. Turned out pretty good. Our winter fall stuff, yeah, everybody knows how much moisture we had trying to get the seed in. Not a huge stand, but we're wanting to look at how feasible it is to be able to support. He'd eventually like to be able to support closer to 130 cattle on that 180 acres. I don't know if we can get all the way there, but I'm still pretty impressed with 110 cows on 160 acres during the summer. So thank you for your time, and I'll take any other questions you might have.
Okay, thanks, Jamie Lynn. This is Clinton, and thanks everybody for joining in. There looks to be a couple questions in the chat box. One from Sandra that was just curious how many cover crops you should include in a mix, or does it truly depend on our primary goal?
And probably all of your speakers could talk about that, but yes, it really depends on your primary goal. And you know, like I kind of touched on for the cattle side, I have found, and most of my producers found, especially for our winter ones, which that's our more common one that is grazed, going 1 grass species with 1 pound of a brassica seems to be what they like the best from the cattle side. Okay. The wheat in your cover crop, especially if it's planted in August, you know, talking about your green bridge for, hey, bet you didn't know that the beef person understood this, your wheat streak mosaic and other green bridge for issues, plant health issues. Yes, that is always a concern. And So that's where the not one size fits all. You can, if you're in areas where that is a huge concern, you'll think about that.
Gotcha. Gotcha. And then I had a question for you. I know you touched on it briefly, but did you see any kind of further differences in breeds, or when you had them kind of mixed together in their grazing habits or patterns?
I really did not. There was more of some difference between age as compared to breed.
Okay.
The older animals, they actually seem to move further distances to for their consumption, whereas the younger heifers, they didn't really travel near as much as those older cows on those annuals, which I think part of that was, you know, those older cows. We were on this after a freeze and there were turnips out there. I've consistently seen that those cows who've ever ate turnips or radishes after a freeze, they go hunting them out in the next time, that the next year that they're exposed to them. So I think part of that was those cows were looking for those, whereas those heifers had never seen them before.
Because they didn't move as much. Huh.
Yep.
Okay. Gotcha. Gotcha. And then I know you touched on it briefly too, but I know there's a list of kind of toxicity issues, but maybe could you mention a few more of those that people would be looking for?
So of course our nitrates, that's always one we think about on especially our warm seasons: sorghum sudan, pearl millet, foxtail millet, proso millet, etc. All of those you have to worry about nitrates, mainly in the hay. I've been working on, and a couple other folks out of Nebraska as well, reevaluating nitrates in a grazing perspective. But from your hay perspective, and here's our blurb here. If you're about to feed some sorghum sudan or pearl millet hay or forage sorghum hay, test it for nitrate before you feed it. It definitely, you don't want to lead to, you know, we always think about death, but the nitrates, I think, is more economically stunting if you're feeding it to pregnant animals and you lead to abortion storms more than death. That's what can get you in more trouble.
Sure.
So nitrates are definitely one. Prussic acid, if you're grazing like your sorghum sedans and your forage sorghums. Pearl millet doesn't have prussic acid, so it's a better grazer from that toxicity perspective. Some of your legumes, if they are included at more than about 20% of the diet, could lead to bloat issues. So you have to be managing for that. So those are just a few quickly off the top of my head. And Peter went ahead and put the link to that potentially toxic pub online or in the chat box.
Okay, Jamie Lynn, thank you. And thanks everybody for tuning in. Don't forget to fill out the poll. We've got just a handful of questions that Craig and I asked that everybody fills that out to give us some evaluation tools. And does anybody else have any other questions? Okay, guys, thank you for attending.
Yeah, thanks everybody for attending, and I definitely think it was a good program. And if anybody needs to rewatch it, it will be recorded, and we'll have